Welcome to this video in the World Around Us series. This is one of the foundation videos, foundations of science, the foundations of chemistry and physics. The foundation, down there below all of the laws and the principles, there is math. There's mathematical formulas, there's mathematical calculations. So I want to talk today mostly about the math. We're going to use density as an example, but we're really talking about math, the process by which the information is transmitted, the ideas of the math. Now, in math, when we have this thing written out, it'll be like this, and all that, plus and all. That is called a mathematical expression. And if you're more inclined to think of things in the world through words than you are numbers, you would be able to say that a mathematical expression is analogous to a sentence. It's a sentence about something, and specifically, a mathematical expression is a sentence about equality. That's why in the mathematical expression, there's an equal sign. It is a sentence about equality. Something on one side of the equal sign is equal to something on the other side of the equal sign. Now, some of you English, some of those people who are inclined towards words and language, you're automatically thinking predicate nominative. I knew you were. The predicate nominative is to say the king is a tall man. And you know it's a predicate nominative because you have a nominative concept at the beginning, and then you have the equal sign verb is, and then you have another nominative type expression here. The king equals a tall man. Now, you cannot have a sentence without the is. The king, not a sentence. A tall man, not a sentence. The king is a tall man. You cannot have a mathematical expression without an equal sign. You cannot. Let me say it again, because I like to repeat myself. And I like to throw Sharpies and catch them, sometimes without looking. You cannot have a mathematical expression without an equal sign. Just as you cannot have a sentence without a verb. The king is a tall man. In math, that would look like something like density is mass divided by volume. So now we have a mathematical expression that tells us something about density. You can change the symbols into words, and you can change the equal sign into an is, and now you have a definition of density. The mathematical expression either creates the definition or comes from the definition. Density is mass divided by volume. Density is D equals M over V. Very simple mathematical expression. So now, what do we do with this? Where do we go from here? We'll do a distance equation instead of something that's this simple, something that's going to require us to use our mathematical written expression techniques a little more fully. So we're going to borrow from physics. We're going to grab the distance equation, and we're going to use the distance equation to answer a question about how long something takes. So the question would start off something like, how long does it take, blah, 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 blah. So how long does it take? That's going to tell us that we are looking for time. How long does it take? For a runner to complete the 100-yard dash, so that's going to tell us the final distance. The final distance is going to be 100 meters. If the timer begins when the runner is 2 meters from the starting line, so that's going to give us an initial distance of 2 meters and runs at a rate of 10 meters per second. So the velocity is a very quick 10 meters per second. in order to make this simpler and to move faster, we're going to let A equals 0. Acceleration equals 0. Now, we've identified all the variables and what we're looking for. The question becomes, what formula are we going to use? Now, some of you are going to freak out and you're going to go, I don't understand this motion thing. You'll get to that eventually. I'm just going to write this down and just follow along. So the final distance is equal to, where were you when you started, plus how fast were you going and how long did you go that fast, plus did you accelerate, and if so, how long did you accelerate? Fortunately for us, this is going to go away. That's 1/2 AT squared. Now I have the equation. I'm going to plug in my numbers. Again, you don't have to understand what this means, but you can just take the numbers and plug it in. So the T is what we're looking for. DF is 100. The equal sign has to come down. We do not have a mathematical expression without an equal sign. If we try to get away without using the equal sign, then we're not really doing math. We're doing something that it'd be like slang if it were English. We want to make sure we're using complete mathematical expressions. Our written expression needs to be complete and it must include an equal sign. And most of the time, we want the equal signs to line up or nearly line up. DI comes from here, 2, plus VI is 10, and T is what we're looking for. That's the multiply symbol, plus 1/2 times 0 times T squared. So 0 times T squared is 0. 0 times anything is 0. So then now I have 0 times 1/2 is also 0. I'm also going to bring my plus sign down. 10T is going to multiply together. The 2 cannot add to the 10. That's bad math. The 2 and the 10 are different in terms of T, so the 10T has to stay together. So now I have a complete expression. 100 equals 2 plus 10T plus 0. I don't have to write this anymore. Plus 0, I do not have to write that anymore. There's my complete mathematical expression. 100 equals 2 plus 10T. I'm keeping my equal signs in a straight line. Now, if I want to simplify this, I've got to get the T by itself. I've got to get it into this form, T equals. So I want the T by itself, so I'm going to need to get the 2 over there with the 100. Mathematically, we call it combining like terms. In order to get rid of the 2, I want to subtract 2 from both sides. And I'm going to write it out completely. 100 minus 2. I'm bringing my equal sign down. I'm going to scooch it over just a little bit. Equals, now I have to do minus 2 on both sides. 2 plus 10T minus 2. Now sometimes people will not completely write this step out. Skipping steps is risky, but it's commonly done. But now I'm gonna combine like terms again. 100 minus 2 is 98 equals 2 minus 2 is 0. 0 plus 10T is 10T. Again, I need to do the same thing to both sides of the equal sign. Now, a lot of people will jump ahead and they're gonna say we need to just divide by 10. This is correct. And what that's going to look like is 10, 10. Then the 10s will cancel. 10 divided by 10 is 1. 1 times T is T. So we can, in fact, cancel those. And that's going to give us T by itself and 9.8. So 9.8 equals T. Every expression has an equal sign, and it has something in front of the equal sign and something after the equal sign. This is good written expression for a science problem. This is a way of saying this equals this, and if I plug the numbers in, then this equals this equals this, and it is a complete expression all the way down. You cannot just start writing one side. You have to write both sides of the equation all the way down. This is going to be true in any of the science math that you will do. And if you get away by shortcutting, then you're getting away with something. You're not completely expressing the mathematical equation. You're not completely saying what's happening mathematically if you leave out either side or the equal sign. So this is a required way of expressing what is going on mathematically. We need these expressed steps in order to keep clarity in what we're doing with the science math. That's what we've got. I hope this was helpful. If you're new to science, if you're just getting your feet wet scientifically and expressing things like this, I'm sure this is a little intimidating to see all these letters on the page. Don't get hung up on that. You plug in the numbers and you do the algebra. You plug in the numbers, you do the algebra, and each step along the way, you have that equal sign and you have the this and the that. This is this. Let me know what you think. Leave me a comment, question. Subscribe to the channel for more videos of this and whatever else I do. Also, thank you for watching, and we will see you in the next video. I'm just going to start over.